recording. Okay, so let's get this process underway. The next thing is obviously a vendor component name, and we want to find out what that is. So we have 4 different types of components that we use in TSD, and they all operate differently. The number 10 question is, what is a TSD BOM compiler and what it does? We're going to go through that, and what files are created when we go what we call through a locking phase. Next week we'll cover locking, and we'll show you what locking is all about so that you can get an idea of how it works and what you can do to get it so that you can get the best out of it. Okay, now I'm just going to go through these questions one by one, and you can actually see what I'm going to do. I'll stop the slideshow, go over in and show you how this works live as we go on some of them, not all of them. Okay, so the first question is, can you change the length of a project number? So due to the SOLIDWORKS flexibility, we can put any numbers we want in there, but we've restricted it to 4 numbers. And we've restricted it to 4 numbers because basically if you follow certain systems, 4 numbers is quite easy to use. 4 digits. You'd be lucky to do 9,999 projects within 1 year, probably even within a company's life cycle. However, 4 seems to work quite nicely. So every file in the system starts with a project number, which is perfect for the EPDM Vault. There are ways to represent other numbers, such as adding a prefix or a suffix to the drawing numbers. And down the bottom I've got an example of how Quadro Design, the company that I work for, because we have a team of people that do beta testing for the software and also work on live projects. So you can see that they've got a project number which is 142080, and they actually use the 14 to represent 2014. And then you can go down through the path and then you'll get to the 2080. You'll notice the 2080 is the same as what's in the very first project number. The 2080 is the TSD number for the project. So what is a project assembly name and when is it created? Well, the project assembly name is the first assembly that gets created and is placed in the top level project folder. Okay? The project assembly is used when a multidiscipline or multi-user environment is created or required. So I'm just going to escape out of that, go back up one so that you can see how that sits within the file structure. You've got an example there, and you can see that the TSD projects, if we look at this example, and then we've got 004, and then we've got 004, which is the actual project assembly name. Okay, and then you'll see folders here, 0004-AA, AB, B8. They are area assemblies. Okay, and we'll get into that so I can show you how all that works live. Okay, so we go over to TSD. I'm actually in an area assembly, so we've got 0002-AA. When we create a project, the very first bit of information you have to put in is a default area assembly, and then you log into it. And when you log in, that's when the assembly gets created. Let's have a look at the file structure for this one so that you can see it live. So there's my project, and in there I've got the top level project file, and then I have my area assembly, which is what I'm currently in. Okay, and then inside that I have the area assembly, which is what I've got open. You can see the backup file there, and then we've got a members folder. This is an area assembly, and we can create as many of those as we like. If we go into the TSD projects under the WBS manager, and here you can see I've only got 1 in there. So if I wanted to add 2, I just go AB. Now a WBS code is a 2-digit code. We prefer to use letters than numbers because numbers you only get 99 different, whereas letters we get 26 letters by 26 letters. So we get so many different combinations. At the end of the day, I prefer to use letters. Letters work the best. And then you can give it a name. We'll just call it anything you like. Test 2. Actually, I prefer you type in capitals, and that'll add the second WBS. And you can keep adding as many WBSs as you like. Now what this does is this adds it to the database. Okay. At the moment, there's no assembly for it. So if we go back up here, I don't have another assembly. But as soon as I log into that by going to TSD Projects, Project Login, okay, I can pick my WBS code and I can log straight in. So when I log straight in, it's created the assembly. I'll just do a Control-Q, Control-S, and you have a look here. Now we've got the AB folder, and we now have the AB assembly. Okay, so basically what this does is it creates the assembly process for us to start working. That's the area level, okay? I'm going to go back to this area here, and I just need to let the database know that I'm in there. To do that, I've got to go back to AA and then log in. That just lets me know that that's the current project I'm working on, lets the database know I'm currently working on that. Okay, so that's the area level assembly. The project level assembly I'm not going to touch on because that's pretty much for multi-user environment. If anybody gets involved in multi-user environments, come and see me. We'll certainly go through that. Okay, let's go over to the next slide. So we've just covered the area assembly, which was what we just looked at, the WBS assembly. Okay, now these assemblies are manually added, as you saw. And also with that, we'll go over to the member assembly, okay? Now, a member assembly is the next level down. So that's the third assembly down as we go through the structure. So we've gone through area assembly at the top, project assembly at the top, area assembly below that, and now we're into the welded member assembly level. Okay? And we'll just go back down to that slide. That's the area. This is the welded member assembly. So it's a sub-assembly that sits inside areas. Okay, it contains connections, sections, plates, vendor items, dummy components, and fasteners. Okay, a welded member assembly can be a frame, it can be a driving sketch, it can be columns, beams, stairs, all that sort of stuff, etc. Now, welded member assemblies sit in the members folder under its own corresponding folder name. Each member has a distinct code associated to the type of member. And as you can see, we've got the project number, which is the 0004. Then we have the area, which is AB. We then have the code, which determines what that actual item is, and it's based on the project library's code that we put in. And I'll show you how that's worked through the library filter and the DMS manager. The next 3 digits, and as we go through, is the sequential number of the assembly. Okay, we haven't had a project where we've had 999 of the same type in it, except for the very large 1 million part project that I actually have. And it does get used sometimes, but at the end of the day, you've got to be able to break this down so that, you know, if there's going to be 999 DSs, you're going to have to come up with a new code for your project. It's very rare. We haven't had it happen apart from that one. And obviously, going to be working on large projects, you're going to have to come up with breaking it up so it ends up in different areas, which, you know, might be AEC or AD. So you can see how that's broken down. Okay, so let's have a look at that in a live model. I've already inserted a frame. Okay, I know this is a frame because the code has got FR in the front. Okay, it's in area AA, and you'll notice consistency in the filing. Inside that, we have a part, and you'll notice it's got the same consistent file name up to the D01. Now, D is a dummy component. We'll go through that in a moment, and this is where I've got my driving sketch inserted. So when I go to insert something in my project from my library, so if I go columns, grab a column, I've got different columns in here, pick a line and insert a column on that line. The column comes in with all of its components, and it's automatically filed and named for me, so I don't need to think about it. You'll see the columns come in. I know it's a column because of the CM, and also with the CM, you'll notice I've got sections in here, and you'll see the consistency in the naming, AA, CM, 001, MO1, and then the connections, which are the next level down. These are the assembly names. That's the next one coming up, so I'll cover that in a second. And you can see the consistency in the way that the filing occurs. Now, this is completely divorced from what was in the library. This is now a project model. And everything that came in with this, there were drawings. Okay, so everything's got a drawing. Everything has a drawing. So because we put it in the model like that, we actually detailed it up, put it in the library, and we've got a drawing in there for it. So you can see how it automatically files everything. And then when I go back over to my filing system, in area AA, okay, there's my assembly for AA. I have my members, and there's a whole heap of stuff here that shouldn't be there, that should be removed, that I should have removed from before. Anyway, that column that came in is that one there. Okay, everything to do with the column came in automatically filed. We've got the assembly for the column, we have the drawing for the column, we have the section in its drawing, we have vendor item that happens to be in that one for some particular reason. This is an old model I should have removed. And those are the connections that are in it. So we've got a base plate and a cap plate. Okay, that's how the filing system works inside TSD. We'll go back over to the PowerPoint, and let's go to the connection one. Okay, so now this is how a connection is created. You can see that inside the connection we've got a huge file name. Don't be afraid, it all makes sense. Okay, obviously that's the weldment that it belongs to. Okay, that's the area it belongs to, so you can see how I'm peeling it back as I go. This number here is the sequential number of the connections. So if you've got 99 connections in one member, you're doing really well. That's a hell of a frame. And then we've got the code for a connection, which is an end plate. And the end plate is got a sequential number of 01 in that, up to 99 different end plate connections in the library. Okay, that comes from the library, that code. And when we look at what's in the library, okay, under TSD projects, this is the library filter manager. Okay, when we go to insert something from the library, we go in here and we set it up so that we can put something in the library and reset it again and grab it. So basically we've got disciplines. So I've got a structural discipline. And then what we have is a code, AA, right through all the way down, if you follow it all the way down to ZZ. Okay. Now if you can imagine an Excel spreadsheet, on the left-hand side in the vertical direction you've got A to Z, and across the top you've got A to Z horizontally. So in AA, in the cell, I've got test. And as I scroll down, you'll see that there are awnings under AW. We've got BE for beams, BL for block out, bin, so forth. As we go through, you can see that there are different codes. Okay, those codes are linked to the actual name of the item in the library. When I select it, you'll see that there is a supplier. So this is the third level of the filter. That was the second, and the discipline is the first. So under the supplier, I can actually add any supplier name I like. Let's just say it was a vendor item, so I'd pick under here. I scroll down, I got a vendor discipline, and then in here I've actually got codes that I can scroll to, and I've got a ball mill kibble, I've got a blower, a ball mill there, and if I scroll down further, under ball mill I've got a TSD. Now the ball mill could be supplied by a particular supplier, so you want to put the name of the supplier in there. This helps you so that when you go in and you go to insert something, you can grab it from the list. So let's just go frames. And you can see the three filters. So I've got structural. They're the three filters that we saw before. We've got the model types. So each one of these is a summation of all the information under the structural discipline. And every single one of these has a 2-digit code against them based on that library filter manager for the DMS manager. And our supplier that comes in as well. And these are the models that we've uploaded to the library. So we've been able to filter out everything to a point where we can just grab things as we need them. Now, under the members area, these have all got shortcuts to all the different codes. These are basic default settings for TSD. They're usually a shortcut, and the shortcut to the filters, okay? However, if it's something that you don't want, you can actually go into here and change it to suit what you want. So I've just switched over to handrailing. And you'll also notice that as there's more and more, you'll tag across, so there's more in the library to grab if you want to grab them and put them in. So as it gets further and further in your library, you can keep going backwards and forwards. Now, that is the discipline, the DMS manager, the library filter manager for welded members and for parts. Okay, our parts library is exactly the same. So when we go to insert a part, we get the same menu. However, we're going to have one for our connections so that when we go into our connections, we can filter them out fairly quickly. Now our connections only have one filter because they're simple really. You know, you've got angle end connections, you've got bearing, bridging connections, you've got base, brace, and you can add any one you like to the code. And every single connection that we've got in our library has been put in through here. So when I go to select a connection and I go to insert a connection, I can actually just go click and there's my base. So these are all my base connections. I can actually go through. These are all the filters for all the different types of connections we've got in our library. Okay, cap plate connections, brace connections. Okay, and that's how the code works for connections, because connections are very similar when you use the TSD project's connection type manager. We've got the Excel spreadsheet thing happening again here from A to Z, A to Z. And that's a really good thing because then we can find them based on their code. So when I go to insert something from it, it puts this code in automatically for me. So for a column, CM, it puts that code in for me automatically, which is really handy. If we go and put a beam in, so members, beams, grab a beam, put it in. Beams have got the same codes. So you can see there under that beam I've got a BE. And if I go into it, just do a rebuild, it's all BE for all the codes for beams. Okay, and that comes from that default library filter system that we've got. Now if we go in and we go, let's add another beam, Okay, and we'll put one there. Hi, Luna. Yeah, we'll have questions at the end, guys. It just makes it easier because we've got too many people online, and if I answer questions, it could take a while to get through what I've got to get through. There's a fair amount of stuff to go over, okay? So I've just put a beam in, okay, and you see how it's labelled at the next consecutive beam. So we'll just do a rebuild on that, get rid of that red cherry that's in it. And you'll see the beams come in and it's got connections and all sorts of things in it. I'm just going to remove this connection so you can see a connection and how it goes in. Okay, and I'm just going to remove the items that are associated to the end of that connection, so it's just a beam at the end. I should have grabbed the absorbed info. Okay, there's also another trim here at the end, which is this one. You sure can. We're having video interference for someone there. Okay. If you can hang on, it could be basically me. We've got too many people on, or it can possibly be that when I'm moving, I'm talking at the same time, which is what I've had in the past. So I'm just going to put a connection in. So if we just put in an end plate connection, go down to here, and I've got one in my library that I can grab. And this is an end plate connection, so I'm just going to pick the members to which the connection goes in. And yep, it's thinking about it. Just have to be patient. When I've got a lot of people online, it starts to slow down a bit. I do apologise, guys. Yeah, I can see it thinking about it. Just have to be patient with this one. It doesn't happen all the time, but because we've got a few people online, it does slow down, so I do apologise. So while that's doing its thing, we'll go back over to the slideshow. Okay, so for a connection, when it goes in, it's going to place in the welded member code, and then it's going to work out what the order is in its sequential order for the connection, and then what particular type of connection. Because this is an end plate connection I'm putting in, it'll come in as EP01. Okay, the obviously all the filing as it comes down to the bottom here, EP01, so forth. Okay, now what we're going to do is get into dummy components and check that connection to see if it's going in. Yep, it's still going in. Okay, there's my connection. Now you'll notice the connection as it's gone in. It's labelled it, and it's an older connection that I've got in there. And you'll see the name of it. So CN03 EP08. So it's the 08, that's the 8th connection in the library. And CN03 means that it is the 3rd connection in the assembly. Okay, so if we just filter it out, you can see that that's the 2nd connection. There's the 2nd connection, the 3rd connection, and the 1st connection that was in it I deleted. So it keeps adding to the connection list as I work. That way the old connection is gone and it won't be reused again. Okay, the filing associated to that has all happened in the background, so that when I do have a look at that beam and I open it up, okay, you can see that the filing has occurred. So there's my CN03, and this is my connection that I've just inserted with all of its files. Okay, now we're going to look at dummy components. Okay, this is a dummy component. Dummy components are excluded from the BOM, and they must contain a solid. Okay, they're hidden using TSD Utilities hide excluded components from the model and drawings function. They have the letter D, which represents the dummy component. They don't contain data, and they're only just usually used for spatial constraints to hold bolts in place and for plates in place. Okay, and you'll see where the D is. So we've got a D that comes in the 3rd digit from the right end. Okay, and you'll notice the filing of it. It's got a D. Okay, a dummy component contains no data. It can contain plates. It can be a section, steel section, weldment profile. It even can be just a basic extrude just to space things out. Now the function of a dummy component, I'll just move this down, as I said, is for spatial constraints. So that dummy component there is used to be matched against the beam to which it's attached to, and you can see that the plate that's associated to it is matched to the actual section size. So if I was to go and change the section size of that dummy component to something significantly bigger, okay, and I might have to reset its position as well because it's an older connection. The newer connections were 2014. They automatically stay where they are supposed to sit. Anything prior to that will move. So I'm just moving it down. And because it's used as a spatial constraint in the connection, it means that that plate now has moved out because it's mated to the face of this beam. And that's the dummy component. Now, to actually hide the dummy component that's in there, we go into the utilities. We've got what we call hide excluded components, and we've got hide excluded components in BOM. Now, hide excluded components means that it's been excluded from the BOM. So that's how you get rid of the dummy component, okay? That connection obviously needs a bit of work, but I've just inserted it. I haven't done any work to it. Now, if I want to bring it back, I can. So I can just go show excluded components, and that brings it back. And you'll also notice that the bolts are all excluded as well. So we'll get into why that happens in a moment. Now, that's a dummy component. The dummy component contains, or it shouldn't contain, any information whatsoever inside of it. So its custom properties and its data is dead. There's nothing there. Primarily because the only functionality that this thing does is just for space, just to spread things out. Okay, we'll have a look at a couple of these dummy components, as you can see. Okay, there's a dummy component here that's used for a beam that's pushing the cat plate down on that column. Let's have a look at the column. So open the column up. So at the top of the column, we've got a dummy component. We use the TSD utilities, hide excluded components. Now, the beautiful thing about it, as you work and you start hiding excluded components, you can actually go in and use SolidWorks as great functionality where you can go in, click on the assembly, and then so that we've got all these components that we don't want to load in, we actually click on Do Not Load Hidden Components, and they don't load in. They don't use any of your RAM. So I believe, I'm a strong believer of that. When we log in, we actually have that functionality built into TSD so that it doesn't show that or hide that. So hidden components are gone. If I was to get out, get back in, hidden components, don't load them. They don't get loaded into memory, so very large assemblies are really good for using these dummy components for spatial constraints. Okay, so I'm just going to show them again. And you can see in this particular instance, I could set up a dummy component in the column connection with the base plate connection that can be used so that when I change the actual connection itself, change the section in the dummy component, the base plate will change in size as well. So you can set that up to do that. That particular connection has not got that in there, but you can. Okay. So that's a dummy component. Let's have a look at what other components we've got. Okay, we have a section component. A section component contains a weldment profile, a structural member feature, and the file name uses an M. Okay, same as a dummy component in the way that it's filed, we use an M instead. Okay, now this gets treated differently with a BOM compiler, and I'll show you what the BOM compiler is in just a second. The BOM compiler creates the data that's required to be able to fill in the BOM and for us to create an MTO. So the BOM compiler, when we run it for a member, will grab the very first cut list item, okay, from the cut list, and it will copy the description, which is a weldment profile's description, and paste it into a custom properties. Now, TSD uses a one body part, and the reason for that I'll get into later. It's faster, stable, better, rebuild times are minimized, all that stuff, and let's put it, if you put it to the test, 500 bodies in one part is better than 500, so let me say that again. 500 parts on a rebuild is faster than 500 bodies in one part. If you want to prove it, try it. Anyway, SolidWorks' limitation is the rebuild of the CPU rebuilding features. So if you've got 500 features in a part, it's got to go through and rebuild all that. We can change a part fairly quickly with one body. Anyway, I'm not going to get carried away with that. We'll just continue on. If you want to have that discussion later, we can. Just ask me questions. Also, with the process of running the BOM compiler, it puts the weight in, it puts the length in, okay? The length is copied from the cut list, and it's a formula, and it's pasted into the custom properties. Okay, let's see how all this works. All right, so here's a section. You'll notice the M. We open that up. We go to the custom properties of it. There's nothing. Okay. It is the first cut list item in the list. Make sure that that's the case. Okay, if we have a look at the properties for the cut list item, we've got the length, that's the formula that I'm talking about. The description for the section, which comes from the weldment profile, and the weight is determined based on the part to which this resides. And that'll be determined by the material, being plain carbon steel and its density. There's nothing in this part at the moment. Okay, now if I was to run the BOM compiler, which is under TSD Utilities, BOM compiler, I can update all the steel sections to plain carbon steel. I'm not going to do that, I'll just untick it. Now this is just going through everything that's in my project right now, and it's doing what we will go through right now. I go back into the actual part that we were looking at, have a look at the properties, and now we've got the custom properties filled out automatically for us. So we've got the section size from the weldment profile, we've got the formula for the length, and then we've got the weight. That's all been added in automatically via TSD. And the BOM compiler. That happened to every section. So this one as well, if you have a look at that. Section size, length, and weight. That only happens with members, okay? That's the M. Okay, with the M, we can also get it in a connection as well, like a dummy component. You can have an M, and you can have an M in a welded member. Let's go to plates. Plates are exactly the same, except that for a plate, because there isn't a welded member in there or a cut list, TSD works out what the bounding box is for a plate. All plates in TSD are drawn on top plane in a sketch and extruded in either direction. So you can do a mid extrusion or you can do an up or down extrusion. Doesn't matter. Either way, TSD works out what the thickness is through the bounding box. Okay, so it will work out what the size is of the plate, the weight, and the length, and it will automatically put those in for us. Unfortunately, because I've run the BOM compiler, I can't show you one that is empty without putting in a new one. But if I was to open that plate up, go to the properties, and you can see the mass is automatically filled in for me, the description, and the length. Now, at the setup of your project at the beginning, you can determine whether or not you want to compare this against flat bar. Certain countries use flat bar, certain countries don't. So it's up to you, and you can set that up within your project at the beginning. At the moment, that's just plate, so you get the symbol plate. If it matches a flat bar, it'll put FL there for flat, so you can determine the difference between the two of them. That's what a plate does, and you'll also notice that with plates, every single plate in here has the same code. See the P's right through the list all the way down the order? So that's the plates. Now, we've got three components we've just gone through. We've got a dummy component, we've got a section component or a member component, and we've got a plate component. Now, the dummy component doesn't use any data, so there's no BOM compiling going on in that. When we BOM compile with sections and members, we get data going on, which is automatic. Then there's the vendor component. Now, a vendor component is a component that doesn't have automatic data added in. The reason for that is because you might want to set up a component that may be a piece of equipment. And that piece of equipment might be something where you don't want to change the data in it, so it's fixed. However, there are some requirements. So for a vendor item, we use the V to describe what that is in the part, so that you see the V at the end rather than the M, the P, or the D. And the BOM compiler skips this altogether, and we have to fill it in manually. Okay, so the following fields have to be added to the configuration-specific properties, not the custom properties, because you might want to have different configurations of your model. So we put it in there rather than using the custom properties. It's the only one that's different out of the other two, where you have to put it in the config specific properties and not the custom properties. We need to put in a description, a weight, and a length. Now, each one of these must contain data, and they must match, obviously, the unit type. So a weight has to have numbers and a length has to have numbers. You could use a formula, the standard formula that comes with SolidWorks, to work out what the weight is based on the density, and the length. Let's just say you're going to put in a stanchion. You don't want to put the length in there. You can make it 0. You have to actually put some value in there, so 0 is fine. You're just letting people know, that, or letting the database know, sorry, and TSD know that there is a length there, and it's not going to cause you any issues when you go to create an MTO. So if there's no length, whack a 0 in there. Okay, the description obviously can be anything you like. This is just an example, Staunton type P. Okay, I don't have any examples of vendor items in my model currently, and I don't know if I've got a library in here where I can grab something that's got a vendor component in it. I might be able to. Let's have a look. We'll go vendor equipment, see what's in my list. Nothing there. Let's have a look and see if there's a crusher in my library. There's a couple of crushers. There we go. So I can pick a crusher and sketch point. I don't have a sketch point on this one. I'll just put it anywhere. I think that model's dead. No, there it is. I really need to tidy up my library. Doing all these demonstrations, I've just added bits and pieces as I go, and I've created a nightmare. Anyway, it's only a nightmare for me. So there's a crusher, which is just a model. Now, TSD is not just a structural package. Always consider that. I've modeled all sorts of stuff in here from shelving racks, all that sort of stuff, to hand railing for buildings, right through to pieces of equipment, and anything you like can be stored in the library within TSD and automatically filed. Okay, this is using the same code system. You can see CR inside the name here, and for its component. You'll notice that that component's got a V in it for a vendor component. If we go into the actual vendor component, I shouldn't have clicked that. Whoops. And in this particular case, you'll see how I've used freeze so that I don't do any rebuilds inside the model. If we go in and have a look at the properties, okay, we've got a lot of other bits and pieces in here that shouldn't be there, but anyway, it's there. So the description's been set up just as a file name, so that should be crusher. Okay, the weight has been set up incorrectly as well. The mass has been set up incorrectly, so we don't want mass, we don't want density, we don't want volume. And we've even got mark numbers and all sorts of stuff in there that are not needed. We need to put in length, as I said. Okay, and the material we don't need either. Okay, so length in this case I don't know. You can put in your bounding box of the shape if you want, so that when you do your dispatch list, you can have the overall size of this thing in your description as well. So at the moment, I'm just going to set the units to this thing. There's no material specified, but I'll just put one in so that it's something that's crazy, and it's probably going to play up because the solids are all frozen. So we'll just peel that back so they're not frozen anymore. I don't know why that's working. So plain carbon steel, it's just playing up with it because they're all solids that have been imported. This is a model that's come in from somewhere else, and it's been protected so that they wouldn't let me modify it. However, it's a simple basic crusher that's in the system. So we'll just make sure that our mass is right. Let's have a look at our mass. It's in kilos, so we'll change our units so that the units come up the right way. And of course, you know, we've got both imperial as well as metric. So kilograms per meters cubed. Okay. And that should set the mass up for us so that when we go into the custom properties, no, it's because the carbon steel thing here isn't working. Doesn't matter which one we use, we're going to get the same error. So when you import things, that shouldn't happen, but it has. Yeah. Someone might be able to shed some light on that one. Anyway, I'm going to move on. So now I've filled in the custom properties for that vendor item. Okay. Now the vendor item is used, will be picked up in the bill of materials when we go to do a lock on certain members. In this case, that doesn't have a drawing associated to it, I don't think. So we can just right mouse click and just check. No, no drawing. Okay. My vendor items, I like to put a drawing in there because if you can, with the drawings, you can, maybe at this level it might have a drawing. You'll get a bomb. No, there's no drawing. So I'm just going to make something here for a drawing. So we've got something. How bad am I? I haven't even got hooked up my my drawing templates here. I'm just going to change that out. TSD, when we, whoops, I clicked on a path here, I shouldn't have. Do that again. Not going to let me. Okay, have a sook. Basically, that's a network path there, and I'm not hooked up to the network in the office. Okay, so basically, under the TSD location, under C Program Files, Quadro Design, we've actually got sheet templates there that you can copy from. Last week we went through, or was it the week before? The week before we went through all the templates. Okay, so we've got drawing templates. and we'll just pick one from out of there. And now I'm getting delays because of that network thing that I selected. Okay, and with that, because I haven't set anything else up, we want to load the drafting standard as well, because we've got that in there as well. Okay, now I'm going to insert a model from the list I've got of open things, and by default all of our drawings match every single item that goes in. Okay, so I'm just going to, that automatically created sections, scale that up. Okay, so now we've got a drawing, and you'll notice that as soon as I hit Control S, which is save, because of the component that went in, the assembly that went in, the name is the same, and all we do is just click save. It's exactly the same. For consistency reasons with drawings, that's what we do. So all of our drawings match each component to which they go into. So if I was to go in and just grab, say, that plate there, which is this one, I go to open up that plate. The name of the plate matches the actual component. As you can see, that name matches the same name as the plate that's in there. Okay, so now we've got bits and pieces in our model. I've shown you vendor items, sections, plates, dummy components. Okay, so let's have a look at what the BOM compiler does. All right, and let's have a look at what an MTO will do so that you can see what information's come through. So I've run my BOM compiler over this so far, and if I go to my TSD drawings, and under there we've got M material takeoff, you can pick it there, or you can go to TSD drawings here, go material takeoff. And if we go get project data, actually I probably should click on the settings here. This is where we set up our filters for our sections. So if we want to put lightweight steel in here, anything that's lightweight, you want to go in there, anything medium and heavy. And then over here we can actually set out things that we want to measure by length, by surface area, by volume. And under here where it says project materials, we just get project materials, and you can see the items that have come in from my project. Okay. You can see I've pulled in my bolts, I've pulled in my section. This information is coming from the custom properties of the parts. I think my crusher's even in there somewhere. If I look hard enough. There it is. Right at the top. If I go over to the material takeoff, you can see in here I've got my vendor supplied item, which is my crusher. I've got my flat bars, I've got my plates, and all this information is coming from the custom properties of me running my BOM compiler, and then I've got all my bolts down the bottom right-hand corner. I can summarize everything, okay, so that gives me a list of everything that's in my project, and then I can save all that out to Excel. So all my lightweight steel that I've set up as a filter comes in here, medium, heavy, there's nothing in there. Plates, so these are all my plates, and it's come from running the BOM compiler. My flat bars, my vendor supplied items, there's my crusher. It's telling me I need one. Obviously for the crusher you might want to put the name of the supplier of the crusher in the description. Length items, surface areas, volumes, and then bolts. Obviously bolts, I've got 15 of those bolts, and these bolts being M20. Just basic generic bolt. It's got no real description to it or length or anything. So it's a really bad example of what a bolt should be labelled as. Okay, so you can see how the filing system works when you run the BOM compiler. You can see how an MTO is created in the process. Okay, now one thing that I haven't covered that should be in this list is fasteners, so that you can actually see how fasteners are put into our connections. So in this instance you can see in our connection we've got 4 holding down bolts. Inside the TSD root folder, which is C program files, Quadro Design, the steel detailer, we have a fasteners library, right? Now these are fasteners and they're set up a certain way. We don't use SolidWorks fasteners, and the reason for that is because we want people to be able to use TSD with the standard version of SolidWorks. Obviously if you go higher up into the premium and the professional, you get the fasteners library. However, our fasteners are different in the way that they're handled. If I open up one of these fasteners, I'll show you what's in it. And we make them all read-only to protect them so that we don't change them. Now, the name of the fastener itself inside our project is not that crucial, but I'll show you what you need to label it as. Now, inside of our fastener, we've got a material length, our thickness. So our material obviously is between the underside of the head and the washer. That's called the ply. Okay. Inside our fasteners we have configurations. You can create your own bolts, you can add your own configurations, you can go as crazy as you like. What we've done is we've gone, okay, this is an M36 bolt, it's 240 long on the current config and it's a galvanized bolt and it's grade 8.8. This is an Australian standard. It can be any standard you like in any way, shape or form. That description there is what gets called into the BOM. It's not the file name. The reason for that is, and I'll show you what actually happens with these things. Let's just go up to this connection here. Alright, now all of our fasteners are labelled a certain way. They are virtual components. Even for imperial and metric, because we initially started off and it's a bit hard to go backwards, the name of our bolt needs to start with an M at the front. Okay? The reason for that is because initially we were using metric and we're stuck with the M at the front. We could change it to B, but there's a lot of code that have to change. However, we've just called it M, and everyone knows that if you're using a fastener with the steel detailer, our bolts start with an M. What you describe the thing as in here is irrelevant. You can name it anything you like, because what TSD does is it gets the configuration name. You'll also notice that it's excluded from BOM. The reason for that is, I don't know if any of you have ever done a large model and dropped the project in and you've got bolts in there. You want to come back an hour later, maybe two, wait for the BOM to get created because you've got too many bolts in there. TSD handles these fasteners differently to the way SolidWorks does. Okay, it picks up the fact that they are virtual. It also picks up the fact that they are excluded from BOM and counts them automatically for us so that we don't have to worry about them. Now you can show them or you can hide them. It's up to you. Either way, you can use the hide or show fasteners, which we've got as a utility. However, you want to count them, and to count them, they can be hidden, which is not a big deal. We go into that member, as I showed you before, we can actually show them and hide them. So under the utilities, if we go hide bolts, they're gone. Utilities, show bolts, they're back. Just as simple as that. So we've built that functionality in there for our customers. Now there are some nice little features that we've got for fasteners at the moment. These are holes, these are fasteners that are already in this connection. 2015 we've got this nice little populate bolts thing, which picks up the lists of all the bolts out of that folder I just showed you. And you can pick that face, this face, select the bolt size you want, and hit your tick. And that'll remove the bolts out of the connection and put all M16s in place. It will automatically make them virtual components for you. It will automatically set up the ply and it will automatically work out what the length of the bolt should be. Okay, they're M16 bolts that have just gone in. Okay, that's fasteners. Fasteners are quite simple. Okay, and as I said, they are virtual, so that there's no external files. They're actually kept inside the assembly that contains them. Okay, they're kept inside the assembly that contains them, and the lengths and material thicknesses are manually adjusted unless you're using 2015. So you can actually change that dimension there to be whatever you want it to be, and you can change the configuration of the bolt just by going in and selecting the config. Something extraordinary long if you wanted to. And you can group the whole bolts by grabbing them all and changing them all at once. Alright, so we've covered a few things there with the way the filing's all done. I guess just going through all that, I think I've got one more question in the list. When we lock something, okay, this is called a phase. I'm going to cover this next week. There are file naming conventions that are used for locking, and you know what a locked component is when you see it because it's different to the other file names. Okay, a phase means that we've gone from an initial design into a final design. A locked phase means that we are almost finished. However, you can unlock and you can lock. You can unlock and lock, which some of our customers have done. The SE that you see there for a locked section, okay, that's changes. Everything changes in how it's filed. There is a respective folder to which these reside up in the project level. So when you lock something, the SC goes into the sections folder, the PL goes into the plates folder, and the VN goes into the vendor folder. And the old files that they used to be remain where they are, so that if you need to unlock, you can go back to them again. A locked process consolidates your plates and your vendors only, and we'll get into that next week so that you can see why it only does plates and why it only does vendors. So that pretty much covers a little bit of an insight into what's going to happen next week as far as locking goes and how the filing system works, because you'll see all this filing system stuff work. If you've already downloaded TSD, please, if you haven't, do it, download it and install it. If you've got any problems, just let me know. I'm happy to help. If you install it, set it up, go through the tutorials that are in our task pane. Okay, our tutorials are over here. This stuff will show you all the tips and tricks. It'll show you what all the filing systems are all about. Okay, because we've got the filing system here. If you just click on that, it comes in. There's the page for the filing system that we just went through. Okay, if you go over into the tutorials, we've got tips and tricks. Okay, it tells you what you can and can't do. Oh yeah, one more thing I should cover is fasteners. You can't have in-context relationships with them. SolidWorks have got a little bug in the way that you handle external references with bolts. With virtual components. So go through this. If you haven't, go through it. Test yourself. Don't be afraid to break it, because that's how you learn. Breaking it is how I learn. I get into software and I pull it apart to find out what it can and can't do. And then you ask the questions. So go through that, and in there you'll see how fasteners are done. I think we've got fasteners in there. On one of them shows you how you can drag and drop a fastener in, how you can add things to the library, how you can insert things, and you'll see how all the filing automatically works for you, so that you go, okay, I can see how this works. Obviously, the more you use the software, the more you'll understand how the filing system automatically works for you, and it will save you an enormous amount of time when it comes to working within SolidWorks. You'll also notice that there are no pack and go processes. We've removed that process. So what folder is this going to? How do we get that folder? All that is removed because it does it all for you. Because when I add a new item into my project, it automatically files it. When I copy a new item into my project, it automatically files it. When I want to start something new in my project, which is one of the very first tutorials, go to TSD members and go to blank member. This is how I start something new. Structural, driving sketch, hit my tick, and that'll put in a blank member for me. You'll see it there automatically, and it's got an F there, which means that it's fixed, but it's not mated to any driving sketch frame or anything. I can start working away in there. Sets me up with a dummy component to put my sketches in automatically. So I can just go straight in here on my top plane, start drawing like crazy. Any sort of sketch you want. Obviously you constrain it. I don't condone having non-constrained sketches, apart from TSD and the way that it works, in the way the members attach to the driving sketch initially, but then it becomes constrained. Okay. That covers the filing. If you've got any questions, I'm going to mute you, and please don't all talk at once, because it'll be a moment. All right, let's go unmute all. Okay, so if there are any questions about the filing that someone would like to ask. Was that pretty self-explanatory, guys? Was it easy to understand?
Michael, I got one question.
Is that Pradeep? Yep.
Yep, that's correct. I'm Pradeep, sorry. If you change the weldment name in the utility, or where it is, that one in utilities,
Yep.
That's right. Modify model custom properties.
Yep, this one here.
Modify, yep, that's right.
Yep.
And where it gets stored afterwards, that name.
So if you want to put in, say, description.
Because yeah, that's right.
Yep. I want to go to the vendor model.
It gets stored there.
Okay. Yeah. That information there goes into the custom properties. Okay. If I go both weldment,
custom properties.
Yeah, see how this has come in with its information under description. If I just go members,
Yes.
okay, there's my members, and I put in the description field. I know this is a little bit off target. This is another feature,
Yep, that's right.
This is another feature altogether, which I probably should cover another day, but you can see how modify multiple custom properties is the process here that we're looking at, guys. It means that if I wanted to modify a whole heap of components in one go by putting in a field name and then the value of it, I can do it here.
Okay.
So if I want to put in a mark, get models, and in there I can go, I want to use the file name for a mark. Okay, mark is the field, and I go update models, and now when I go into these members, or these sections, in the custom properties, it's put in the mark field, and it's put in the actual value that I had selected.
All right.
That's what that does. Does that answer your question, Pradeep?
Yeah, that's, but then when you save in the drawings, it saved, when you open again, it doesn't appear to be there in the drawings.
Oh, you got to link the drawing.
It just vanished from there.
Yep, let's just go to the drawing, okay?
Initially, yeah, it is like a, yeah, if I go in the drawings.
So I'm in the drawing.
Right.
I'm
at
in the drawing.
Bottom.
Yeah.
Yeah, that's.
This is SolidWorks functionality, by the way.
The drawing.
This is SolidWorks functionality. This is not TSD. So if we go into the actual link to property,
All right.
select the component.
Yep, you link the property.
And you can grab the component property. Actually, I didn't click on the actual object. So let's do that again. So I need to click on the beam. That's the component to which I've selected. And there's the mark number, and there's the OK. Okay.
That's right.
That's how
Now,
you
when you close this,
save it.
when you close this one here on the model and open again, it doesn't appear to be there in the same drawings.
Should be.
Yep. Log in the project again.
Should be. Still there.
See this one here now, AABB is just.
Okay, so it's still there. This, we'll have a talk about this one later, Pradeep, and find out what's going on with you, okay? That sounds like that might be a SolidWorks issue.
Yes, sir.
Okay?
Any
questions related to today's webinar?
Thanks, Michael.
No problems. No questions? Did everyone learn something new? No, all good. Richard, good. Mohammed, any questions? Aluna, any questions? Phil, any questions on what I covered, mate? No? All good? John, no questions? No? Okay, no problem. I'll give you the link, Aluna. Not a big deal. Okay, so that pretty much covers the filing system within TSD and the data that is required. Obviously, for certain reasons with vendor items, you want to add that data in before you add it to the library, because if you reuse it over and over again. Okay, whoever's talking, I can't hear you guys. I'm just going to mute you. Okay, so if we are going to add vendor items to the library, we want to put that data in first, because if you don't, you put it into the library, and if you're working in a multi-user environment, people start inserting that item into their projects, you're going to have to go in and add that data in over and over and over again, and you're just going to frustrate people because now you've added a whole heap of work to an unnecessary situation. Our 2015 does an audit to make sure that that data is in there before you upload it to the library. We've got a little smart on that, and we want to make sure that that data is in there. All right, so you can see how the BOM compiler works. You can see how the data works. Next week we'll show you how locking works and how filing works with locking, and you can see how the BOMs are automatically created using that. and the MTO we've just covered as well, so you can see how all that process works. So I just want to thank you for your time, guys. I really appreciate you being here on the end, and I hope you've learnt something about how TSD's filing works for you. If you can't see the value in what we can do with having automatic filing, please give me a call and I'll make you see it. No, just kidding. I just think you should really have a good look at this. So download TSD, install it, have a go at it. If you haven't got SolidWorks, try and get a copy of it somehow. I know some resellers that could possibly set you up to give you a 30-day trial. Just jump on, put TSD on there and give it a go, see what happens, because I tell you, it saves me a lot of time when I work on projects. And we're getting 5 times the speed out of TSD on top of SolidWorks. Well, I am personally. The others in my team are a little bit slower because they didn't develop the software. But anyway, that's just one of those things where it takes time. And I guess if you're using the software over and over again, you get familiar with the processes. At the end of the day, I can't see why you wouldn't get to 5 times the speed. It may be a year down the track or 2 years down the track. It just depends on how quick you learn. Now, when I say 5 times the speed, we've tested it. We've done a study, and I was used in the study with another guy who uses SolidWorks, and we've actually found out that through just this process alone, it can help big time, considerably in the time. And it stops frustration. Now, this is a consistent filing system. So whenever someone asks me for support, I can get straight on there and I can see what they've been doing and I can help pretty quick. Whereas in the past, if it wasn't a filing system, people name things certain names and I go, what the hell is that? Try and work out what it is. This is pretty simple for me to work out. And I'm sure that if you did work in your office and you had another guy in your office and they were going to pick up your project, the naming and everything is the exact same. So there's a lot of logic behind why this has been done. We have a 12-digit maximum code. Some CNC machines, which we're working towards for DSTV, only have a certain number of characters that you can use to inscribe onto sections, and that all depends on what machine you're using. So we've got 12 digits as our maximum. We don't want to venture any further than that, and the code that we've got seems to work quite well. All right, guys, so next week we're going to cover locking. We're going to make sure that you get a fairly good understanding of what locking is all about, how to troubleshoot some locking issues that people get. Obviously, we've got some features in here that some of you will not know about when you lock, and going into that locking phase and what that means, what you can and can't do, and then what you have to do if you want to do certain things. So we'll certainly cover that next week. All right. So thanks very much for your time, and hopefully you get on to the next one, because next one's going to be a big one for all of us. This one was simple. It might be a little bit daunting at first, but once you start practicing, you'll be right. Okay, so we'll see you next week. Thanks for your time, guys. Catch you later. Okay, so if we are going to add vendor items to the library, we want to put that data in first, because if you don't, you put it into the library, and if you're working in a multi-user environment, people start inserting that item into their projects. You're going to have to go in and add that data in over and over and over again, and you're just going to frustrate people because now you've added a whole heap of work to an unnecessary situation. Our 2015 does an audit to make sure that that data is in there before you upload it to the library. We've got a little smart on that, and we want to make sure that that data is in there. All right, so you can see how the BOM compiler works. You can see how the data works. Next week we'll show you how locking works and how filing works with locking, and you can see how the BOMs are automatically created using that. And the MTO we've just covered as well, so you can see how all that process works. So I just want to thank you for your time, guys. I really appreciate you being here on the end, and I hope you've learnt something about how TSD's filing works for you. If you can't see the value in what we can do with having automatic filing, please give me a call and I'll make you see it. No, just kidding. I just think you should really have a good look at this. So download TSD, install it, have a go at it. If you haven't got SolidWorks, try and get a copy of it somehow. I know some resellers that could possibly set you up to give you a 30-day trial. Just jump on, put TSD on there and give it a go, see what happens, because I tell you, it saves me a lot of time when I work on projects, and we're getting 5 times the speed out of TSD on top of SolidWorks. Well, I am personally. The others in my team are a little bit slower because they didn't develop the software. But anyway, that's just one of those things where it takes time. And I guess if you're using the software over and over again, you get familiar with the processes. At the end of the day, I can't see why you wouldn't get to 5 times the speed. It may be a year down the track or 2 years down the track. It just depends on how quick you learn. Now, when I say 5 times the speed, we've tested it. We've done a study, and I was used in the study with another guy who uses SolidWorks, and we've actually found out that through just this process alone, it can help big time, considerably in the time. And it stops frustration. Now, this is a consistent filing system, so whenever someone asks me for support, I can get straight on there and I can see what they've been doing and I can help pretty quick. Whereas in the past, if it wasn't a filing system, people name things certain names and I'd go, what the hell is that? Try and work out what it is. This is pretty simple for me to work out. And I'm sure that if you did work in your office and you had another guy in your office and they were going to pick up your project, the naming and everything is the exact same. So there's a lot of logic behind why this has been done. We have a 12-digit maximum code. Some CNC machines, which we're working towards for DSTV, only have a certain number of characters that you can use to inscribe onto sections, and that all depends on what machine you're using. So we've got 12 digits as our maximum. We don't want to venture any further than that, and the code that we've got seems to work quite well. All right, guys, so next week we're going to cover locking. We're going to make sure that you get a fairly good understanding of what locking is all about, how to troubleshoot some locking issues that people get. Obviously, we've got some features in here that some of you will not know about when you lock, and going into that locking phase and what that means, what you can and can't do, and then what you have to do if you want to do certain things. So we'll certainly cover that next week. All right. So thanks very much for your time, and hopefully you get on to the next one, because next one's going to be a big one for all of us. This one was simple. It might be a little bit daunting at first, but once you start practicing, you'll be right. Okay, so we'll see you next week. Thanks for your time, guys. Catch you later.